Hi students, in this video I'll be going through the 2022 Mathematics Paper 2 question 6. Right, so this is a question regarding properties of circles as well as similarity as well as concepts like Pythagoras theorem. Okay, so let's read the question. Okay, the diagram shows two circles that touch at C. A, B, C are points on the smaller circle with center O. C, D, E, F are points on the larger circle with center P. A, O, C, P, E, B, C, D, and D, P, F are straight lines. So over here we have one very long straight line, A, O, C, P, E, right across. B, C, D straight line, D, P, F also a straight line. Okay, so in part 1, we are asked to find angle DEP. Alright, so let's mark out the angle DEP first. So DEP is over here. Right, so DEP is in this triangle, is in the triangle DPE, right? Okay, so if you look at this triangle for circle property question, you must always look out for isosceles triangle. So this angle that we want to find is in an isosceles triangle, which makes our task easier because if only we know just this angle, right, then we will be able to use 180 minus this angle DPE and then divide by 2 and we'll get a DEP. And indeed, it's so obvious what this angle DP is. It's just vertically opposite DPF, right? Right. So that's how we can arrive at the answer. Okay, so let's go ahead and write down this solution. So angle DPE, okay, is equals to angle CPF. Okay, angle CPF, sorry. Okay, which is equals to 96 degrees. Okay, so this one will be vertically opposite angles, right? Okay, then angle DEP we'll just use isosceles triangle. So angle DEP will be 180 degrees minus angle DPE, and then we divide by 2. Okay, so we'll get 180 degree minus 96 degree over 2. Okay, which is 42 degrees. Okay, so this one, the reason will be isosceles triangle DPE. Okay, so over here we can fill in this angle already. This is 42 and this is 96 degrees. Alright, so just like this we get part A. Okay, let's take a look at part B. Okay, so part B is a similarity test question. Okay, show that triangle ABC is similar to triangle FCD. Okay, so ABC is inside the small triangle. FCD is inside the big triangle. Okay, so if you look at this question, at this point in time, there are no lengths given, right? So if there are no lengths given, then it's not possible for us to be considering the SSS test or the SAS test. So it means that we need to consider the AA test. Okay, so we should start looking for angles that are equal in both triangles. Okay, so if you look over here, we have diameters in both triangles because the chord AC passes through O, right? So if you have a diameter, then the first thing that you think about would be a right angle in a semicircle. So indeed, the right angle in a semicircle for the small circle will be over here at angle ABC, and then for triangle FCD, the line the chord DF passes through the center P, right? Okay, so the right angle in the semicircle will be over here. So we already have 1A, right? So maybe we can write this down first. So angle ABC equals to 90 degrees, right? So this is the right angle in the semicircle. Okay, semicircle. Okay, then the next one will be angle FCD, okay, also 90 degrees. Okay, so this is also right angle in a semicircle, right? Okay, so therefore, we have our first A already. Okay, angle ABC equals to angle FCD. Right, so we need to have one more pair of angles that are equal. Okay, so if you look at what they want us to show, they want ABC, right? So in other words, angle A corresponds to angle F. So angle A corresponds to angle F. Okay, then the other one that we can use will be angle C correspond to angle D. So which one do you think will be easier for us to show that they are equal? Okay, A or C? Right, so if you have guessed C, then that would be a good choice. Why would I choose C? Okay, so in math we must have a reason for everything we do and a purpose, right? Right. Okay, so why would I choose to start thinking about C? It's because C is closer to the other triangle. C is the angle in the small triangle that is closer to the big triangle, so it will be easier to relate. Okay, indeed, the moment you mark out C, you can see that we can straight away translate via vertically opposite angles to the other side of the other circle. Although this angle DCP is not inside the triangle, it's not an angle in the triangle FCD. But over here, if you look, there's another isosceles triangle. CPD is an isosceles triangle, right? So this means that this angle will be equals to angle CDP, right? Will be equals to angle PCD. Okay, and angle CDP is inside the triangle that we want, the big triangle FCD. So now we get our second A already, right? So once again, why did I choose to start from angle ACB? Because it's closer to the other circle. Okay, so it's easier to make a transition to the other circle via some property. Okay, as considered to angle A, right? So we can go ahead and write down our solution. Alright, so angle ACB. So we'll go from left to right. Start from angle ACB. So later our ACB is equals to angle DCP. Okay, so refer to a diagram. ACB equals to angle DCP. So this is via vertically opposite angles, which will in turn be equals to angle FDC. So this is due to isosceles triangle CPD. Okay, so FDC is this angle over here. Okay, so now we have AA already. Okay, okay, the first one, angle same, and then the second A2 and A2. Okay, AA, right? So now we have proof using AA. So therefore, triangle ABC is similar to triangle FCD, okay, via the AA test. Right. Right. So I hope you are able to understand, okay, my thoughts on how I approach this question. Right. Okay, let's move on to part C. So this question is actually not an easy question, right, to solve. Alright, so for part C, they start to give us some lengths. So the first length that they give us is this DE over here, which is 7.21. Okay, then DF. Okay, so DF is 9.70. Okay, the whole thing. Okay, the diameter. Okay, then after that they give us BD. Okay, so BD is the line that cuts across both circles. So this is 9.10. Okay. Okay, angle CPF, okay, the repeat again is 96. Actually, it was mentioned in the part A already. Okay, so now they want us to calculate the length of AB. Okay, so if you recall, in part B, we actually proved similarity, right? We proved that triangle ABC is similar to triangle FCD, right? We proved that these two triangles are similar. Okay. At the same time, we also managed to find out that DEP is 42 degrees. Okay, so we'll fill it inside the diagram 42. Okay, so the fact that they ask you to prove similarity in the second part, right? Okay, you should have an indication that maybe they want us to use this similarity. Okay, the fact that these two triangles are similar, right, to help to solve this question. Okay, so let's try to dive into this. So if you recall, one of the important aspects of similar triangle is that the ratio of corresponding sides are equal. Okay, so for myself, usually what I recommend you is that if you want to find AB, right, you put AB on the top left hand corner. Okay, so this is a very good practice actually. So AB corresponds to FC, all right, the side FC. Okay, then the next part I'll try to use a length that we know. So you see this 9.10 is the length of DB, right? Okay, so at least we know the total length of DB. Okay, so if you had asked me to choose, I would choose BC to be the next corresponding side to use. So BC will correspond to CD. Okay, so if you look here, I want to find AB, right? Do I know FC? So FC is over here, right? Okay, so I don't know it, but maybe later on I'll be able to find it. All right. Okay. So this one still don't know. Okay, but maybe later I need to find. Anyway, this is a 4-mark question, so there should be a substantial amount of working to be done. Okay, then the next part would be a BC. I don't know, but can I find? Okay, so I also don't know. Okay, then CD. Am I able to find CD or not? Okay, so if you look at recall, this is a right angle triangle. Okay, CPE is also a diameter, so angle CDE is going to be 90 degrees, right? So we have a right angle triangle. We know the 42. We know one side, which is 7.21. We can use trigo ratio to find CD. And once we know CD, we can find BC because the whole length BD is 9.10. So these two is settled already, right? Okay, then after that, can we find FC or not? Remember over here is also 90 degree, right? So once I know CD, I know DF, I can use Pythagoras theorem to find FC. Then I know all these three, I can make use of this ratio of corresponding sides to find AB. Right, so this is a rather complicated question. Okay, not easy. Okay, but with careful thought and planning, you will be able to get the answer. So I hope you can see my thought pattern. Okay, I use the similarity, the property ratio of corresponding sides are equal. Then I write down all the things, okay, that I need, and then I try to tick one by one and see what I can find. All right, so this is how I go about doing the question. Okay, so the first thing is to find the length CD, right? So I need to tell the examiner how come I can use trigo ratio. So I need to write down the angle CDE is right angle in the semicircle. So let's start. Okay, so angle CDE equals to 90 degrees. So this is a right angle in a semicircle. Okay, so it's a right angle in a semicircle. So now I can use the trigo ratio already. So tangent 42 degrees. So why do I use tangent? Okay, because remember now I want to find CD. CD is the opposite side, and this 7.21 that I have is the adjacent side. Right? So it will be equals to CD over opposite over adjacent. Okay, so CD is going to be equals to if you calculate out, it's going to be 7.21 times tangent 42 degrees. Okay, which would be 6.4919 cm. So I write more decimal place because it's a working step. Okay, so I found CD already. So CD is 6.4919, right? Okay, so once I know CD, then I can find BC, right? So BC will just be 9.10 minus 6.4919. So that will give me 2.6081. Okay, so I found two things that I need for the equation. So this is 2.6081. Okay, so this is BC. Okay, then we should just use a Pythagoras theorem for triangle FCD. Okay, to find FC. Okay, so using Pythagoras theorem, Pythagoras theorem for triangle FCD. Okay, we will have FC equals to the square root of DF in this case the hypotenuse. Okay, so hypotenuse square minus CD square. All right, so CD we found earlier 6.4919 square. Okay, so this would give me the answer of FC to be 7.2073 cm. Okay, so I found all the lengths that I need already. So now I can go ahead and use this okay, this ratio of corresponding sides to find AB. Okay, Okay, so triangle ABC is similar to triangle FCD. Okay, so AB, okay, which is what they want me to find, right? AB, okay, AB over FC equals to BC over CD. Okay, so I just plug all the values that I found earlier. So 7.2073 equals to BC is 2.6081, okay, over CD, which is 6.4919. Okay, then if you do the calculation, AB is going to be equals to 2.8955. So round off to 368, 2.90 cm. Okay, so you'll get this. Okay, so by no means an easy question. Okay, so in fact, this I would say a rather difficult question. Okay, for this chapter. All right, let's look at the last part of the question. Okay, so last part of the question, they want us to calculate the length of the minor arc AB. Okay, so where is the minor arc AB? So minor arc AB would be this one, right? All right, minor arc AB will be this one. Okay, so if I were to draw out the sector, okay, so I join with the radius over here and over here. Okay, so to calculate the length of the minor arc, I will need to know the minor angle over here, right? So this minor angle over here. Okay, so how do I get this angle? Okay, so this is something that we also need to think about over here, right? Okay, so for let's write down some of the lengths that angles that we already know. So this is 42 degrees. Over here we have 90, right? Okay, so this angle AOB, which is what we want to find, right? Do you agree with me that it's the angle at the center? Okay, so if you from point A and B you extend out to the center, you get this angle AOB, right? Okay, for in this small circle, can we find an angle at the circumference that extends from A and B? So if A and B you further extend out, okay, then this will be the angle at the circumference. So that means if I know angle ACB, I'll be able to multiply by 2 to get angle AOB. Right, so this is one angle that we need to find. Okay, so maybe we try to find this angle first. Right, so let's do it. Angle ACB. Okay, so angle ACB is in this small circle. How do we relate it to the other triangle? So by vertical opposite, we can come over here, right? And we know this one is 90, and we know it's 42, so we should have no problem finding this angle DCP, right? So angle ACB equals to angle DCE. The angle DCE in turn is 180 minus angle CDE minus angle CED. Alright, so minus these two. So 180 minus 90 minus 42, you will get 48 degrees. Okay, so this one will be 48. So by angle at center, okay, equals to twice angle at circumference, we can find angle AOB, right? So angle AOB will be 2 times angle ACB. Okay, so this is angle at center. Okay, so over here, write the reason vertically opposite angles, right? So angle at center equals to twice angle at circumference, right? So we'll get 2 times 48 degrees equals to 96 degrees. Okay, so now that we found this angle already, all we need to do now is to find the radius. Okay, find the radius of this circle, because we will need to use 96 over 360 times the circumference of the whole circle to get this arc AB, right? So how can we find the radius of this circle? Okay, so far, what lengths do we have? Remember just now we found AB already, right? So AB is over here. So just now we found AB to be 2.90. Okay, but we'll use the more accurate value, 2.8955. And then BC we also know. Okay, BC is the 2.6081. Okay, 2.6081. And this triangle, AC is a diameter, correct? AC is a diameter, so this means it's 90 degrees. So I can use Pythagoras theorem to actually find the diameter. Right? Okay, so that's what we're going to do. Okay, so by no means is this an easy question. Okay, so using Pythagoras theorem, for triangle ABC. Okay, we want to find AC, right? AC is actually the hypotenuse. Okay, so you will get square root AB square plus BC square. So you get square root 2.8955 square plus 2.6081 square. Okay, so you'll get 3.8969 cm. Okay, then we can then calculate the length of the minor arc already. So length of minor arc would be the angle at the center, subtended by the arc, the angle subtending the arc, okay, over 360 multiplied by the circumference. So circumference is actually a 2 pi r, but we can also write it as pi d, right? Okay, so this is the diameter, pi d, d being the diameter, okay, 3.8969. Okay, so you'll get your answer to be 3.26 cm. Okay, so this to 366. Right, so you can see that questions like this can appear in your exam, and they are certainly not easy to do. Okay, but I hope you understand my thought process. So spend the time, okay, when you see a question, spend the time trying to plan your answer, trying to identify the things that you need to find, and then you go about finding them one by one, and you get closer to solving the question with each and every step. So don't rush into the solution, okay? Pause, take a step back, look at what info you have, and then use that info properly.